Hello, my name is Amos Winter and welcome to the MITchanic YouTube channel. I named this channel MITchanic because my day job is being a professor of mechanical engineering at MIT, where I teach about machine design and product design and really celebrating all mechanical things. But my passion and my hobby is this stuff, working on old cars. In this series, I'm going to tell you about how I built up this car, which is a 1983 Porsche 911 SC, which I converted to a track car to compete in the One Lap of America race. In the coming episodes, I'm going to tell you about all the stages I went through to upgrade this car, most of which focused on rebuilding the engine, which now makes 260 horsepower, which is 44% more than stock. We'll go through the engine teardown, the remachining, the reassembly, and how I got those power gains, which largely came from switching from fuel injection to carburation. I'm also going to tell you about other upgrades I did to the suspension, to the brakes, and making it more of a track car by adding a half roll cage, race seats, and race harnesses. My hope is that this series can be a great resource for you, whether you're building your own 911 engine or building your own track car, or just interested in old car repair in general. I'll share with you the tips and tricks that I figured out, as well as the mistakes I made, and hopefully help you prevent making the same ones. And I'll also talk about some of the interesting engineering details that went into the design and upgrades of these cars. Now, in terms of additional resources, there's a few I'd recommend you get right from the get-go of this type of project. The first is this book written by Wayne Dempsey, the founder of Pelican Parts, about how to rebuild 911 engines. This got me probably 90% the way through my engine rebuild process, and it's an excellent resource overall. The second is this Bentley workshop manual, and Bentley makes manuals for really all air-cooled 911s. So pick this up. It'll teach you about how to fix really anything in the car. The next is you should find yourself an engine machinist. I had to do work on the heads and the cylinders of this engine, so you need somebody really skilled in that type of machining work. And I went with a guy named John Androok of Circle Performance on the South Shore of Boston. I'd highly recommend him. He did a fantastic job. But you'll probably want to find a machinist in your area where you can easily take parts to and from. I'd also highly recommend speaking with a guy named William Knight, who's almost this folk hero presence on the Pelican Parts forums about 911 engine design. He was super knowledgeable about choosing compression ratio, pistons, and sourcing the carburetors for this engine. And then finally, you should educate yourself with the online communities about these cars. And great resources are the Pelican Parts forum as well as the Rennlist Forum. So with that, let's start this project and go down memory lane all the way back to 4 years ago when I started this whole thing. And I apologize in advance for all the bad pandemic haircuts and actually a different workshop that I used at the beginning of this at our old house. So with that, let's start with the engine teardown.
What you're going to see now over the coming hours is stripping down this engine, rebuilding it, and hot rodding it. What I'm going to be doing to start with is taking off the intake manifold in the CIS fuel control system. Now these systems are kind of notorious for restricting fuel and airflow because of emissions restrictions from the early 1980s and late 70s. So what's probably going to happen with this is it's just going to get replaced by some carburetors or maybe fuel injection. But the first thing we have to do is take it off. We can put it aside and then get to taking down the rest of the engine. That with the CIS system, you probably don't want to take everything apart, particularly if it's working, and this one was working when I took it out of the car. So you can just take a few bolts out and put it aside and just store it as a whole engine. Another thing I want to touch on is what hardware to use. And so what I recommend getting, and I'll put the link to these tools in the description, is just this swivel socket set. I bought this off Amazon. It was pretty cheap. And if you compare the relative size of the universal joint with a regular socket to these swivel sockets, here's the 12 millimeter. In comparison, so it's super, super tiny, and you can get into tight spaces a lot better. Now, I apologize for this being kind of like a cooking show. But before I started shooting this, I did get all the fasteners off the intake manifold so it can come off easily. I disconnected all the wiring harness elements. You also notice that there's no transmission on this engine, so I took that off. It's also missing the clutch, but I wanted to show one of the fasteners and how easy this swivel socket is to get in there. So there's a nut right here, and this fits perfectly. You take that off. But once you get all those fasteners off, you can just kind of shimmy this up and lift it up. And it should come out as one unit. And I just dropped that washer down the intake, but that's okay. The engine's going to work. So, there we go. And the CIS comes off as just one big piece. And you can put it on the bench. So, I would say be a little careful. Ooh. More careful than I just was. Those flex joints seem a little loose. But I was going to say, be a little careful with the injectors. When you set it down on the table, you can kind of squash the injectors, and they're pretty delicate. I wouldn't want to squash those. So I'm going to lay it on its side like this, and then find a box and put it in a little bit later. So now, we're left with the block. Let's see if I can fish out that washer. Yeah, so a tool that I recommend everybody have in their workshop is a magnet on a stick, because you can get down into tight places and pull out a washer like that. Another thing I recommend to anybody doing this is get a bunch of plastic bags, label each one. This one says CIS system mounting hardware, and then you will not forget, inevitably, like a year from now when you're trying to assemble things, what goes with what. So when I store this, it's going to go with the CIS system. And then another pointer I recommend is that I think it's really valuable to label all the connections. I use just masking tape and write with a Sharpie. And, oops, that's been recording the whole time. So I use masking tape with a Sharpie and label all the connections. And I'm usually pretty descriptive. White connector on CIS above cylinder 2. So that's giving me, what this is connecting with and the relative location it goes with. Why that's important is you can see the wiring harness here is stretched all over the engine, and you certainly want to take a lot of pictures to know where everything lies, but these labels will also help you know what goes where and how the harness drapes over the engine and what's supposed to go where when you assemble it back together. So what I'm going to do now is start attacking the exhaust manifold. About 2 weeks ago, when I stopped working on this for a little while, I flipped this over like I'm going to do now. Oh, it's also important that you use a proper bracket to mount the engine to. These are aluminum blocks. They're not super duper strong, so you want it so it mounts and distributes pressure evenly, but also these brackets, again, not a paid endorsement, but you can get these from Pelican parts, and I can put the part number for this in the description. Check it out if you want to buy this. But it's made to bolt up with the engine. I had to modify it a little bit so it didn't hit the exhaust, but it was just grinding off a little bit. So here's the situation we're in. I've gotten all the nuts and bolts off. Actually, they're not bolts. They're either socket cap nuts, where an Allen wrench can go in, or a regular nut. All of them off except one, and this one's really sticky. I broke 2 of the head studs, which is not a big deal, because I'm going to replace those anyway when the block's redone and refinished. So I have to get this one last nut off, the head stud, so I can take the exhaust off. I'm now going to do the probably the wrong thing with the right tools, or maybe the wrong tools to do the right thing, but I have to get this really finicky little nut off. The only tool I have that will fit in there are my handy swivel sockets, and these things, again, are fantastic. They've gotten in all the small places. The problem is I don't want to put a ton of torque through here because it's just a 1/4 inch drive, and I don't want to shear off the tool or shear the pin in the universal joint on the swivel socket. But this thing's being really obstinate, and I need to get it off. So I'm going to have to use the breaker bar to do it. And so the way we're going to do this is gently. So this is a breaker bar going through a 1/4 inch drive, which technically is a bad idea. Ah, good. Whew. Broke the head stud, which is fine, and not my swivel socket, which would not have been fine. Yay, good. So, get that out later. Now, this should lift off, but I guarantee it won't because it's probably rusted solid. So, we need to give it some mechanical persuasion. Blow mallet. Now, if I hit up on this, that, I think, if you're lucky. Oh, yes! The exhaust is heavy and almost off. Yay! Victory! More of a U than a V, but victory nonetheless. Now we're going to start tearing this down, and we have to start with the top side of the engine and remove the fan and the fan shroud and the wiring harness. So I'm going to flip this back over and probably spill more oil on the floor while doing it. Now what we need to do is remove all this wiring and take the harness off, as well as remove all the spark plug wiring, and then take the fan shroud off so we can then take the fan off and the alternator off. So, throttle cable. We need to first start probably by taking the spark plugs out. We don't need those now anymore. I'm going to replace all of them anyway. I'm just scoping this out, thinking about what bolts to take off when. I just read the description of the recommended order. I think what I'm going to do now is put this on a time lapse because it's pretty straightforward. You need to take the shroud, shift it back. You can unhook the wiring harness on the alternator, which is in here. It connects to this part of the harness, the main harness. So then that whole thing can come off, and then the top of the distributor is already off. I'm going to keep the wires connected so I know which goes to which cylinder. I'm going to label the plug-ins so I know which ones they all go to. And then hopefully we can lift this whole thing off. The throttle linkage, this is the throttle linkage. This plate needs to come off. And then there's a few caps here. There's a cap over the oil cooler, which is right here. And the belt needs to come off too. We're finally at the big moment where I think the shroud should come off. Sweet. I'll have to pull the wiring harness through the shroud so I can separate them, but that's great. Now I wanted to just comment briefly on this little piece. I've never actually seen the backside of one of the fan shrouds in a 911 engine. I've never disassembled one to this extent, and I think this is such a cool piece. One, because it looks really cool. It looks like, you know, like some sort of fish or like a Roman like soldier's helmet or something, you know, with these two fins. But from a fluids perspective, it's pretty interesting why Porsche decided to do this. My guess is it's kind of an afterthought, that they hadn't realized they needed these fins when they first designed the air-cooled engines, because you would think that the fan would suck air in, you'd get basically a manifold because of the shroud and a high pressure region everywhere, and it would blow air through the cylinders and cool everything. But what I suspect actually happens is that as the air comes in, a vortice is imparted to it, because the fan spins this way. And so the air is coming in like this, and there's probably not a lot of flow resistance down through the cylinders, so it can go through rather fast. And if these fins weren't here, I think what would happen is it would come in, and you'd end up getting a higher pressure here on this bank of cylinders, and air being somewhat trying to be sucked through upwards these cylinders. Not really. You'd end up just with a lower pressure here and a higher pressure here. What that would mean is you'd get more flow rate of air through these cylinders and less through these, so these would get cooled more than these, and these could get too hot. So what these two little blades do is, as the air comes through and that vortex is imparted to it, these two fins can grab some of that airflow before it all has time to turn and go down through these cylinders. These two fins grab it and direct it down through the cylinders here on the left. So you get a more even distribution of airflow and more even distribution of pressure being applied, air pressure being applied to both cylinders, so you get more equal cooling. That's a pretty cool design and a really sweet looking part. The last part of the fan assembly to take off is the fan itself. And you need this special tool, which comes in a standard 911 toolkit, which can hook into the fan and enable you to undo this large nut that holds the pulley on. I just consulted the directions again, and I don't think I actually have to take the fan off. And I was wrong when I said before it's aluminum. It's actually magnesium. At least in the older cars. I don't know if this one is or not, but it's fragile. So I'm going to keep this on as is, because there's really no reason to take it off, actually. All I'm going to end up doing is cleaning this up. Maybe I'd have it blasted, media blasted, and like powder coated, but I'm probably going to be too cheap to actually do that, because it's perfectly functional the way it is. And I can probably just clean it up with some steel wool. But I think if I take this off here, this one bolt, this Allen bolt, I think the fan will just come right off. So let's see. That takes the strap off, and hey, there we go. The fan can come out. Cool. So here we go. Here's the fan and the alternator. It's really a compact alternator compared to, if you look how thick this thing is, it looks pretty tiny compared to a normal, like, front engine car's alternator. I might need to replace this though. This is cracked. But it was charging, it was working beforehand. Some of this shroud is cracked, but I think it's still good enough and usable. I don't know if this shroud is aluminum or magnesium. Either way, it's expensive to replace, so I'd rather not replace it.
Here's the challenge. To get the ring that holds the cooling fan off, I think I'm going to have to pull the distributor, and I think it would also help to take off this bracketry, which actually holds the engine to the car. think it's worth getting a quick shot of all the detritus that's falling out of this thing. It's crazy. Ugh, gross. So here we go, taking the distributor off, and hopefully, oh, that went well. That not loosened up pretty easily. There's a good amount of corrosion on the block, and so this aluminum is all kind of white and flaky. But you're supposed to, oh good, the distributor's pretty loose, and typically I've done this on my other 911, but it should just pull right out. There should be an O-ring that's holding it in place. I had to use a little bit of mechanical persuasion with this small pry bar, but I did get the distributor off, and then, all right, out. So, yeah, it's held in with an O-ring right here, and that's what seals it into the case, but also what was making it tough to get out. It looks okay otherwise. The bearings spin fine. But yeah, the gear teeth look okay as well. So I've taken off the distributor and the oil pressure sensor. Which looks like it has a brass washer, sealing washer. I won't lose that because I'll forget to get another one. And so now this ring, this clamp ring for the distributor fan should come off. Apparently you can thread it through these holes, and they recommend not to bend it any more than necessary. I'm sure this part is not cheap if you get a new one from Porsche. Well, let's try the other way. I have to kind of coerce it a little bit. There's a bend. It's acting as a stop here. There we go. Look at that. So, success. Smiley face. All right, good. I didn't have to bend it so much. And this should be reusable. There's nothing really wrong with it. I may paint it, but it's in pretty good shape otherwise. Now we're going to start on the interesting part. This is what's called the long block. So we're going to start with the oil breather, and then the oil, I can't remember what this does, pressure switch, and there's another pressure switch right there. And then I think we can start taking off the heads, which is going to be really exciting. It's worth mentioning just for a second why you'd have an oil breather. So this is just a tube that actually goes back to the oil reservoir. And it's because as the pistons are moving up and down, they're actually changing the volume inside the crankcase. And so you want some airflow back and forth, otherwise you'd just be compressing and expanding that air and losing more energy to air pumping and that compression of the inside air inside the crankcase. This is a pretty cool part right here. I just pulled it out of the engine block. It goes right there. I don't want to put it back in because it's all dirty. But this is the thermostat. And so this is a, I think if it works like a thermostat in a water-cooled car, this is a temperature actuated valve that allows oil to be sent, I guess in this case probably up front to the forward heat exchanger that's in the right front wheel well of 911s. And what I love about this is it's a purely mechanical solution. You could solve this problem by having a temperature sensor that's hooked into a microcontroller that's attached to an actuator that when it measures the right temperature, it'll open a valve and send oil somewhere else. Or you can do it with just some thermally actuated and thermally changing system that, if you have a metal or a spring that when it gets hotter, it expands. You could use that to open a valve. And so I love that about old style mechanical technology and trying to find simple, really robust mechanical solutions rather than over-engineering it with, I guess, more modern, high-tech technology. Next up is removal of the oil cooler, which is right here. And there's actually two oil coolers on old 911s. Here's the one right by the engine, and some airflow comes from the big cooling fan and then blows down out the bottom of the engine and goes through this heat exchanger. And then the other one, as I mentioned before, is in the front of the car, in the right front wheel well. The four nuts holding the oil filter, or sorry, the oil cooler, are now off, and it pulls right off. And to reveal the home of a small animal before, complete with food supply. There's a bunch of birdseed and nuts in here, as well as some hair, which is, well, no, this looks like that's synthetic. I guess that was bedding. So we got the kitchen and the bedroom, apparently, of this small animal. But dump all that out. Oh, crap, and some oil that's left in here. Whoops, I should put that in a pan. But now we've got the head exposed, and we can start taking off the valve covers and see what's inside and see if there's any broken head studs. So this is an extremely exciting moment for me. The whole reason I pulled this engine, well, one, because it was old, but the primary reason is because it leaked oil. And it leaked oil, and you can see all the oil film under here, but it leaked oil out of the bottom of the heads, and that oil would actually drip onto the exhaust manifold, which is a pretty big fire hazard. So I couldn't even, after I bought this, I couldn't even really drive this car. This is a really common problem in 911 SCs because they used for the head studs. And the head studs are these long threaded rods that run from the head down through the cylinders and into the block. And they clamp the head to the cylinders to the block and seal everything. So what happens is when the head studs break, they lose that clamping pressure on the exhaust side and allow the head to kind of lift up a little bit, and then that allows oil leakage out of the oil channels that lubricate the engine to leak down out of the engine and onto the exhaust manifold, which lies right here. So what we're going to do now is take off these valve covers, which should give us a look at what's going on with the head studs, and maybe we'll see if one's broken or not. Here we go. Time to take off all these nuts and see what's behind this valve cover. What do we see? Well, it's hard to tell. So down there are the valve studs. And what I'm going to do actually, why don't I just put my magnet on a stick down here. Let's see what we find. I'm seeing if I can lift up any of these valve studs. Not yet. Doesn't mean they're not broken. They might just be kind of in there, stuck in there from corrosion or something else. Well, that's interesting though. That's one valve cover off. Let's take the other one off. These are cool, by the way. They say Porsche. Nice die-cast parts. Well, looking down this one, it's not clear. It's not readily apparent that any of the head studs are broken. Again, I'll put my magnet on here. No. Huh. Well, still a mystery. Let's see what the other side looks like. again, I don't see any of the head studs broken. Doesn't mean they aren't. We'll have to dig more. Next up, we're going to take the cam covers off. And so what this will give us access to is the chains and the chain tensioners that drive the camshafts as the engine turns. So first I have to take off these oil lines, and if I'm lucky, this is an engine, and I think it should be because I think it's new enough, an engine that has hydraulically actuated chain tensioners. If not, that's an upgrade that I'll have to do, but I think this probably goes to a chain tensioner. When you're taking these oil lines off, I always recommend using 2 wrenches. You want to hold the base nut or base fitting, and so then you can apply counteracting torques and loosen it up. That way you're not overturning one thing relative to the other, and you're not putting too much torque into the block. You're really not putting any torque into the block or the oil lines. I always like taking off oil lines because of how they're designed. This thing I'm taking off right now, this is called a banjo bolt. And I don't actually know why it's called a banjo bolt. It doesn't look like a banjo, but what's cool about it is it has these holes in it. And so as oil comes through this line right here and comes up to this kind of hemispherical head, the oil can flood around these holes and then flow axially down actually the center of the bolt. So the bolt itself is delivering oil. And you always have to be careful that there's usually a seal up at the top of the bolt under the head that clamps down to the banjo to seal it. I've removed the oil lines over the cam cover, and so now it's just taking off a few nuts. Oh, pulled the stud out. Right there. Not the end of the world. I'm sure a lot of these threaded studs are going to get replaced anyway, but it'll be good to keep all this hardware together. So if I need to put that stud back in, I know where it goes. You want to use a dead blow on these. This has some, I think it's lead shot inside. I bought these off Amazon. They're made by Tecton. Pretty cheap. I can put the link in the description so you can get them too. But they're good hammers. Voila. Look at that. That's cool. And 2 good things about this. One, I think I bought the right tool to take this sprocket off for the cam. And 2, it has the hydraulic chain tensioner, which is good. Oil comes in through the banjo bolt, the smaller banjo bolt that goes right there. It's screwed into the outside of this valve cover and pressurizes this little cylinder here. And then there's a rocker arm right there. So this cylinder pushes up, it pivots on this pivot right here, turns this rocker arm this way, and tensions the chain right there. So that's pretty cool. I'll have to take all this out, take this chain ramp out, replace that, but it's really neat to see this. I've never gotten this deep into a 911 engine before and seen the chains. It's also nice too that these engines don't have belts. 911 engines is they use these big beefy chains, so they never break. Or at least I don't think they usually break, but they're like lifetime parts, or at least lifetime between engine rebuilds. What I need to do next is loosen up all the rockers for the valves. So if we zoom in on these, they are the valve rockers are these small arms right here, and they rock back and forth and they push on the valves right here. So the reason I have to loosen all these up is because I'll inevitably have to turn the crankshaft. And you don't want the valves to be pushed into the cylinders and the crankshaft to potentially hit it. And why that can happen is I'm going to take the timing chain off. So the valves won't be moving when the crankshaft moves. So the way these come off is there's a retaining nut that you just undo. And you can unscrew that and then back off this adjustment screw. The reason this adjustment screw's here, which is cool, so if I back it all the way off, you'll see there's some slack here. This thing can move up and down. And the reason this adjustment screw is here is that you adjust it so there's just a small gap between the tappet and the top of the valve. And so the reason you leave a gap there is because of thermal expansion. So as the engine gets hotter, everything in the engine grows in its dimension, and that little clearance shrinks down, and you no longer have a gap. So if you tighten it tight, so you were directly touching the tappet, which is this little spherical joint at the end of the rocker, against the valve, if it was tight when the engine's cold, when the engine heats up, it would actually push on the valve a little bit and could open it a little bit, and you could lose your seal. So that's why you leave that little bit of clearance. And when I put the engine back together, I'll use what's called feeler gauges, which is a little piece of sheet metal that you put in between the tappet and the top of the valve, and to set the gap exactly. Now it's kind of time for one of the main events of taking this engine apart, which is taking the camshafts out. And those camshafts are retained by a large bolt right here that goes through the cam chain sprocket. And you have to unscrew this bolt while not pulling on the chain, because you could damage the chain or the tensioner. So you have to put in a special tool to engage these small holes that go around the sprocket. And so here's that tool, which you can buy from Pelican parts. And it looks like Pelican buys it from Stoddard, which is a Porsche parts outfit out of Ohio. But it's a Porsche tool 9191. And the tool has, this is fun because it's unwrapping this for the first time. The tool has these special fingers that engage into the sprocket, and they've actually been machined down so they're flat and they can clear this big washer around the nut. But the way this is going to work is I have to put the tool in here, and hopefully it fits. I hadn't tried this before, and it does, good. And so that holds the sprocket while I'm going to put another breaker bar on here to undo that bolt. What I need to do is turn this turn this bolt counterclockwise while not breaking the engine. And so the reason this tool works is that I can apply a counter force and not put any tension through the chain. So hopefully, I've not taken one of these off before. Apparently they're quite hard, but I guess I'm super strong, but that was pretty anticlimactic and rather easy. So I think I figured it out, how to get the chains off the cams and start disassembling the cam assembly. First thing is there's a small pin right here that holds the sprocket on the camshaft, and it's actually the same size as the threads. It has an internal thread the same size as the top of a spark plug. Lucky enough. I haven't figured that out, by the way. That's in Wayne Dempsey's book from Pelican Parts. So take that pin out, and now I think I can probably shimmy the sprocket off. On the other side, I was able to get it just with my fingers. The chain tensioners are spring-loaded as well as hydraulically pressurized when the engine's on. So I tried to pry this down just pushing on the cast steel parts, and so I could push it down a little bit and squeeze out some of the oil, but there's a heavy spring in here, so I couldn't get it out. But hopefully I can get this. I'm trying to get a little bit more chain tension, or chain slack rather. Finally, success. I had to put a pry bar in here and I had to pry against this pin that holds the chain guide just slightly. I nicked it up a little bit, but it's fine. It's tapered, so it won't hurt anything. In order to get the sprocket off, but here's what's a bigger issue. So I'm going to take this sprocket out. There we go. All right, this is what I want to show you. Here's the sprocket. There we go. Now it's focused. Here's the sprocket. And you can see that the chain is actually eaten into the sprocket here. And that happened, it looks like, because when it was put together, it wasn't spaced axially correctly. It was too far out, and the chain could hit it and rub against it. So the back side, you can see there's actually no chain markings whatsoever as the chain slid on this face of the sprocket because it wasn't touching. But on this side, it was eating itself. Why that's bad is that if that's rubbing and it's wearing away the metal, it'll actually create metal fragments that'll get pumped through the engine and can hurt the engine. So on the back side here, on the back side of this thing, move the chain out of the way, there is another sprocket type part which rides on a key. So there's a keyway in that. I think you can see it. And then behind that, there's a bunch of shims. And so I'm going to have to probably take one of these shims out so it doesn't rub too much when I reassemble the engine. The last thing I want to do before I call it a night is try to get the cam chain housings off. And so they're held on by 5 nuts, and they're kind of spread all over the place. But take them off. All right, look at that. We're finally at a pretty exciting point in the engine teardown where it's time to take off the heads. So this is also exciting because it's the time when I'm going to figure out if any of the head studs are broken. The way I need to do this is to use a long Allen wrench to get down into nuts that have an Allen opening at one end and then are threaded on the other that thread on to the end of the head studs. I bought this special part. You can buy this from Pelican parts. It's part number PEL-TOL-A10MM. But it's just a long Allen key on the end of a 1/2 inch drive socket. And it's a 10mm Allen. So that'll go in here and lock in. The other thing I did before I started all this was I hit all the top of the Allen nuts with PB Blaster. And they're open, so hopefully that oil has been able to work down into the threads of the head studs. So with that, I can start my first try getting one of these out. I'll start in the middle of the head, and I'm going to put my impact driver on the lowest setting and an easy clearance. This, by the way, is an excellent impact driver. I'll put the link to this. You can get this on Amazon. But I love this thing. It will, take the nut off a planet. All right, here we go. It's on setting 1. So there we go. Now comes the big question, the exhaust side. Are any of these broken? First one, no. The second one. Nope, easy. Third one's okay. Maybe my head studs are not broken. Which is somewhat disconcerting because that would have been the likely culprit of the oil leak. But I don't think this was the leakier side. I think the other one was. There we go. And I just saw the head lift off. So here's what's next. Here's the back side of the engine. And these two return tubes, here and here, that's where the oil flows back into the engine case. And so what I need to do is come in here with a screwdriver, and you'll see when I get the screwdriver under here, I can pry it up and kind of pry these out. These are what are holding the head in right now. What I had to do was pry those oil return lines off and then just tap the sides of the head a little bit, and now it looks loose enough to take off. So here is hopefully the big moment. Oh, ta-da, look at that. That is so cool. We can see inside the pistons. We can see how domed they are. We can see how cruddy they are. But they don't look, all these exhaust studs are existing. They're there. So that's pretty exciting. What I need to do now is take off these cooling retainers. So what these things do is they actually direct the airflow between the pistons, and this is pretty important. You don't want to just get rid of these thinking that you'll free up airflow and free up cooling and improve cooling. That's not the case at all. These are actually made to direct airflow in a certain way, and also my guess would be speed up the air velocity, because if the air is moving faster, you get higher convection, and you can get more heat exchange and more heat drawn off the cylinders. It's just like having a convection oven that has a fan in it versus just a regular heated oven. The fan circulates the air more, and it can improve the rate and increase the rate of heat transfer and cook your cake faster. So in this case, we're not cooking cake, but we're hopefully not cooking oil by keeping it cool. I love parts made out of sheet metal. What's so cool is that this just started as a flat piece of metal, and they stamped it in a die to make this shape, both to shape it with these bumps in it and also to cut it out. And so it's a really, really cheap way to make rather complicated geometry of parts. So whenever I can, when I'm designing stuff, I try to make it out of sheet metal. What I need to do now is secure the cylinder so when I flip the engine over, it doesn't fall apart. You can see this is really loose. I don't know if this was part of the culprit of why the engine was leaking, but this cylinder is a lot looser than, this one's kind of loose. This one's, I guess, a little loose. Maybe they're all loose, but that seems weirdly loose. So I'm going to do this kind of a quick and dirty way. I've got a bunch of spare nuts from another project. So I'm just going to loop them on here, and enough so I can just tighten this down by hand, and it'll prevent the cylinder from falling off when I tip the engine over. Check out how greasy those cylinders are. This was the side that was really puking a lot of oil right on the exhaust. And you can see there's a ton of oil and just sludge built up around there over years. But what's interesting is none of those exhaust side head studs are broken, which would have been the classic culprit for these SC 911s. So I'm not sure if the heads weren't tightened down enough. The studs didn't come out when I undid the nuts. So yeah, I'm really not sure what's causing this. What I need to do first is scribe the number of the piston and cylinder, because if I were to reuse these cylinders and pistons together in the future, you need to match them because of the same size. They kind of wear in and work themselves in, so you don't want to mix and match cylinders and pistons. In reality, I'm going to replace the pistons to a higher compression ratio, but I still want to mark which cylinder goes where in the block. And so this is the right bank, so this is cylinders 4, 5, and 6. The other side is 1, 2, and 3. So I'm just going to etch in on here Roman numerals because they're easier to do with straight lines. So there's IV. You want to etch these in non-mating surfaces. I just did this on the one of the fins of the heat exchanger in the cylinders. You want to do the same on the piston, where it's not going to hit anywhere. Now is kind of an important moment. This is the first cylinder that's going to come off, and we're going to get our first look on what's it looking like in here. So I should be able to, yep, just jiggle this and push the piston down. I've never taken, there we go, one of these off before, but there we go. So there's the first cylinder, and at first glance it doesn't look too bad. There's no, let's see if there's any, no, there's no ridges. I'm just feeling it with my fingernail. A little bit of a ridge on the top, but on the bottom, all in all, not too bad, even though it's a big oily mess. While the engine's upside down, this is a good time to take off the oil drain cover plate. So this is the bottom of the engine. And there's just a bunch of nuts that hold this on. And when I take this off, I should be able to see the crankshaft, which is pretty cool. I'm going to keep these nuts, even though they're nylocks, but since they're nylocks, and the nylon's already been cut by the threads, they're not good to reuse. I'll keep them with the washers, just so I know the size. Ooh. Ah, too bad I can't see the crank. That looks cool though. This is the oil pickup. And so, yeah, this is a pretty neat shot actually. So right here is where the oil gets sucked up by the oil pump, and it drains into the bottom of the sump through this screen. And there's this really cool bowl shape here that it drains under, and then this clearance, this depression that's stamped into the metal here gives a little bit of room for oil to flow underneath and they get sucked up here. This is what's called a dry sump engine, so there's not a big oil pan that holds a large volume of oil. The volume of oil that's circulated through the engine is actually held in another reservoir in the right rear fender. So the reason you do that is you can make an engine that's not as tall, and it can sit lower, closer to the ground, so it lowers your center of gravity and makes the car handle better. And it also minimizes the sloshing back and forth, that if you slosh oil and it gets onto the crank, it can slow down the crank and you can lose power. So dry sump engines are pretty cool, but I've never seen the bottom of the oil pan like this. And then here is the oil plug, and you can see on it, it has this little magnetic part that collects filings and stuff. I've already cleaned that off, that's why it's so clean when I drain the oil. But pretty cool to see this all. But let's see if any of these head studs are ferrous. Whoa ho ho! Hello. Hello again. These studs on this side, these three are ferrous. None of these on the lower side are ferrous. This is a major hint, because this is telling me this engine's been fixed before and some head studs have been replaced. So I'm wondering if when we take these cylinders out, we're going to see that there were some inserts put into the block for these head studs. But wow, this is really interesting. So yeah, these four in the center, these are ferrous as they're supposed to be. These are all steel. You can see I can pull up pretty hard on that. And these on the bottom are not ferrous. So it looks like all these head studs with the yellow on them have been replaced. The next thing I need to do is to start taking off the pistons. And this apparently is a tricky job. I've never done this before. And it's recommended I wear safety glasses because the retaining rings that hold in the wrist pins on the pistons can go flying. Apparently, the correct method of doing this is to sneak a screwdriver in to these slots right here, right there, and pry out that retaining ring, and then pull it out the rest of the way with those pliers. So let's see how this goes. My screwdriver's a little big, but oh, there we go. Oh, that wasn't that hard. A little anticlimactic. There we go. Look at that. Easy. Look at that. And you're supposed to keep the wrist pins in case you want to reuse them. Sweet. Look at that. First piston taken off. Now all the pistons and cylinders are off the block, and there's only a few more steps to take before I can split the block in half. There's a few auxiliary things in the front of the engine still that need to come off. I think this is for the oil pump. This is a small cap that spans the two sides of the block. We need to take this pulley off, and we need to take the ramps off, the chain guide ramps that come out with these bolts. There's 4 bolts on each side. So I'm going to use a breaker bar to get this pulley, and it should just come off. Of note, I have a lock on the flywheel so the engine can't spin. I'm not crashing anything into the engine right now, into the internals. I think this is a right-hand thread. I hope. Whew. There we go. It is a right-hand thread. I didn't just break this pulley off. So I'm going to take a quick picture of this just to remind myself the order I did everything in. So breaker bar selfie, pointing at that nut, or that bolt. Okay. Cool. So this should come right off, yep. And it's got a small locating pin on it right there. Nothing special about this. Keep those guys together. And now I've got to take off these bolts and these bolts to get at the chain ramps. These are kind of cool fasteners. They have a little cutout in them, and that clips onto the chain ramp. And that right there, I think, is the shaft to the oil pump. We're going to see in a minute when we open the case up. But if you want to get just putting those fasteners there, I want to get a close-up look of all this cool stuff. There we go. So that's what I just took off. You can see the parting line of the block is actually right there and there. So that's pretty cool that it lines up so well. You can get a mating surface. And there's a small gasket on the back side of that cover. I don't exactly know why that's there, but that's part of the oil pump. It looks like actually an oil channel there. That might be an inlet or an outlet of the pump. And then here's where the front seal is. It's going to be cool to take that out. There's a seal that presses in right here. It's this piece right there, I think. But there is a seal on that shaft. That's part of the crankshaft. So that's going to come out when we split the block. Next up is taking off the flywheel right here on the back of the engine. And I have the special Porsche-made socket to do this, or it's kind of like a big Torx driver, and so it fits right into these flywheel bolts. The problem is I can't fit the breaker bar in between this and the engine mount. I think what I'm going to do is pop this. There's a little spring pin in here, right there. Pop that out and see if I can push in the tool a little bit farther into the socket head and maybe get enough clearance. I was able to take the socket end off of this Torx driver, which is again a very special shape in order to fit in these holes. So now I have plenty of room, and now I can just put an adjustable wrench in the end, and with a bit of muscling and holding it in place, yeah, nice, got it. So it's really important this that the tool is completely seated in the fastener, otherwise it can fall out and strip. So I'm getting it perfect and then undoing it. The first step of cracking the case is I need to take out 11 of these cross bolts. So the bolts start on this side, they go all the way across the case, and they terminate in these cap nuts. Apparently these nuts have O-rings under them. I'm going to use a breaker bar to start each of these and just get them loose. I'm not using an impact wrench for two reasons. One, I don't want to damage the case, and two, my wife's using the impact wrench. Cool. Ooh. I just heard the whole block kind of relax. So now these should all come off easily like that. Ooh. So here you can see, here's one of the cap nuts. And the reason they use cap nuts is because these are sealed. And actually now I can see it. Here's the washer that holds it. That washer pushes down on an O-ring, or what looks like it was an O-ring at one time. It actually looks like silicone sealant. So I don't actually know if that's an O-ring. But we're going to take all the rest of those off and then pound the bolts out. And I'm going to change the camera battery because it's almost done. Now what I need to do is pop these bolts out the other side. What you never want to do is pound directly on the threads of a bolt, because you can really knacker them and it's then really hard to thread something onto them. So what I'm going to do is just thread these nuts back on a little bit, and that then gives me a surface to pound on when I hit it with a hammer, a small hammer. And hopefully it'll just sneak through. I also have to be quite careful because there's a lot of like sealing surfaces around here. but that's actually coming pretty easily. I can back it off a little more. And then hopefully push it through. Look at that. Whoa! That's awesome. Look at these. That is one beautiful bolt. So the way these work is you can see there's an O-ring right there, and in the washer where it sits, there's a small groove. I don't know if you can see that. Yeah, you can see that. There's a small groove, and when you tighten it up, that O-ring sits in that groove, and that creates a seal. And that's important because these go right through the block, and this part in the middle is in oil. This is in oil right here, and otherwise if you didn't have these O-rings, the oil would leak out of the block. I've decided to take all the head studs out. When I took the heads off, I realized that some of them had been replaced, and I actually looked back in the car's service history. This car came with a huge binder with like every receipt from every service that had ever been done on it. And I found that some of the studs were replaced, and they said they replaced all the exhaust side ones, the ones on this side, but that is not true. There's some originals in here that are of the brittle material that can break. So I decided to take all the head studs out, and so I'm going to be working on that first today to try to get those all out. Now there's a special colleted stud remover that you can buy from Snap-on. Wayne Dempsey talks about this in his book, as well as you can find it on the Pelican parts forums. It's pretty expensive. It's a few $100s, and I probably would have bought it, but it isn't readily available from Snap-on. So I had to think of another way to get these studs out. So what I did is from McMaster Car, I'll show you up close, I bought a few different styles of nuts. So I bought 17 millimeter, that's the outside of the dimensions of the hexagon of the nut. And I bought tall nuts that can engage a bunch of threads. And then for the top of them, as a lock nut, I bought these flange nuts, also from McMaster Car, that have a 15 millimeter hex on the outside. And so with an angle grinder, what I did is just ground off the flange. So here's that nut with the flange ground off. And I can put that on top of the 17 millimeter outside nut. And what I can do then is put an impact driver over the two, grab the lower nut, and back the studs out. At this point, I've now successfully taken off 8 of the head studs, and I think I have the process down pretty well. And so now I want to show you start to finish how I'm doing this, because it's actually pretty straightforward and easy once you get the hang of it. So I'm going to take off one of the original exhaust side head studs. And these are the ones made from the really tricky brittle material, Dilvar. I can't remember exactly what it's called, but it can thermal fatigue and it can break and crack pretty easily. So you want to get this right. You don't want to like bend one of these or snap it, because then it gets a lot more difficult to take off. So the first thing I'm going to do is take one of my 17 millimeter outer hex M10 nuts and thread it on the stud. And I'm going to thread it on so about a ½ inch of the stud's thread is sticking out above the nut for my lock nut, about like that. And then I'm going to put on the lock nut I made, the 15 millimeter outer hex lock nut. So screw that on. Oops. And then you have to lock these nuts against each other. And you want to be careful not to put a lot of bending stress into the stud. So you want to lock them really tight so they don't slip when you put the impact driver on. But try to do it in a way where you're not, when you're really wrenching down on it, not bending the stud too much. Okay, so that's on pretty tightly. And I've found over the last few studs that you really only need 5 minutes of heating. I think Wayne Dempsey recommends 10. I'm finding it works fine with 5. So I'm going to start my timer for 5 minutes. Just put it on the top there and start my blowtorch. And put the blowtorch right on the bore of the cylinder opening of the case. So the torch is going right into the block right at the base of the stud. And so I'm just going to leave it here. These blow torches are not particularly hot. They're not anywhere near as hot as a cutting torch. So you can just leave it in one place and it's not going to damage the case or anything. All right, so it's been 5 minutes. And what I'm going to do now is put the impact driver on the bolt, or on the head stud, and make sure it's going in the right direction. By the way, I've put the torque on the impact driver all the way up to the highest setting on 3. And the other thing I realized is that when I back out the stud, I want to keep the flame right on the case, because this case dissipates heat so quickly that even if I take this flame off for a few seconds, it's going to cool down around the head stud. And that can be an issue, because if the case gets cooler than the stud, it's going to shrink faster than the stud and clamp up against the stud again. So as I take it off, I'm going to keep the heat on, and hopefully now it'll just come right off easily. So here we go. Look at that. Easy peasy. I think I just figured out why this side, which is the right side of the engine, what would be the passenger side of the car, I think I just figured out why oil was leaking so badly out of that side. If you look closely, and I'll zoom in the camera so you can see this a little better. So all of the head studs on this side of the engine have been replaced. They all have little bits of yellow paint on the end, and they're all a non-magnetic alloy. I don't exactly know what they are, but they're not the original head studs. They also have a different, like, black coating on the outside. And I've been noticing with these newer head studs that when I put the nuts on, there's a couple of them on the other side. When I put the nuts on, check this out. I can just undo them. They're finger tight, literally. They weren't torqued down, and I don't think they were Loctited. And so my hypothesis is that over time these loosened up, and by doing so, the engine lost compression on the head gaskets and also lost compression on the seals at the bottom of the cylinders, and that's why oil has been leaking out. But look at this, I just took this out by hand. What I'm doing now is taking off the last few parts on the block that I think would have to be removed anyway when it goes through machining and cleaning. So things like these fittings for oil and oil return, as well as the secondary drain plug. And then I think those are the last parts to take off before I can remove all the nuts on this side that hold this side of the block to the other side, and then I can split it. All right, so I took the 3 remaining nuts off that were behind the flywheel, and so hopefully now the case can split if I tap on this. All right, so I'm gonna flip it over. Good. Just drop back down. That's okay. And now, the moment of truth. Whoa. I feel like the Space Odyssey theme. Da, 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 da. Oh, yes. Whew. This is really neat. Look at that. So this is the crankshaft, of course, connecting to all the con rods, connecting rods. Check out the cam drive gear. And this is pretty cool, actually. This gear has a 2-to-1 ratio because you want the valves to push down only once every revolution, or sorry, every 2 revolutions. You want a valve to open up for a 4-cycle engine, so you need that 2-to-1 reduction there. This is the distributor gear, which is really pretty, and brass. And you've got the 2 cam chains. The cam drive also drives the oil pump. This is the oil pump right here. And I guess once I undo those 3 bolts, it'll lift out. Now, here is the moment of truth. I can lift out the crankshaft by lifting up 2 of the con rods, and there we go. There's just a few more things to do before I can take it to the machine shop. The first is to take out the secondary shaft and the oil pump. The oil pump's right here, and the cam drive, this drives the 2 camshafts of these chains, has a secondary shaft that comes off and drives the oil pump. So this is held on by just 3 small nuts, and take off these 3 nuts, and then this will lift out just as one assembly. You have to be kind of careful because there's no actual connection, rigid connection. You can see this is a coupling right here that sits on 2 splines. So if I lift this up and voila, lift this whole thing up together. This is pretty cool. That J-shaped tube is the pickup for the oil. I'll put this over here on the bench. There we go. Great. So now, this is a bare block. That is it. There's a couple seals here from the oil pump. Guess I'll take those off and save those with the pump. They'll get replaced when I rebuild everything. But yeah, wow, this has been quite a journey. I'm at the last task, tearing the engine down, which is taking off the con rods, the connecting rods from the crank. You want to make sure that when you put this back together, I want to make sure when I put it back together, that the same connecting rod goes to the same lobe on the crankshaft. So I have a scribe. I'm going to scribe which number cylinder each one is. Now this is a little tricky because one side is 4, 5, 6, the other one is 1, 2, 3, but they're jogged back and forth. So actually, I lifted up the cover on the back of the 911 SC right here, where the sticker shows which cylinder is first. So it starts with number 4 right here. And you obviously want to mark this in a place where it's not on a bearing surface. Next thing to do is take these off, and so the bolts, these bolts are cool. They have these ends on them that prevent it from counter turning. I'm going to keep the bolts with the con rods, and you want to do that so at the machine shop when they measure the diameter, they can bolt them down. But when I actually reassemble the engine, I have to replace these bolts because when they're put on, they're actually plastically deformed. They're overstretched. And just making sure I'm not tightening this more. They're overstretched and plastically deformed when they're torqued to spec. So you don't want to reuse them. Oh my God, these are tight. So these are off. And I'm just going to take it off and then immediately put them back together. Come on. Well, this does not want to come off. You certainly don't want to put a screwdriver in the mating surface between the 2 sides. That's a precision ground surface. There we go. So get these off and take this out. Whew. So this is pretty cool. Here's the first connecting rod, and looks okay. Looks like a little schmutz there. Nothing too bad. These bearings are inserts, so those are going to get replaced. You don't want to mess with these surfaces. These are ground, and they mate a very specific way. I've been trying to find a machine shop that can do the machining work I need to get this thing all squared away. And had a really good conversation with the machinist this week about the potential state of the heads of my car. And I want to show you those. Flipping around. And I have the two heads side by side here. This is the right head and the left. And you can see they're quite different colors. The right head is all gunked up and it's got oil all over it. And the left one looks pretty clean. So what I think happened is that on this head, the studs loosened up, they backed out, they unscrewed, and as a result, there was a gap that formed between the head gasket and the head itself. And that's what caused all this oil to like blow out and become disgusting. So that's potentially an issue because of these sealing surfaces. The contact area between the cylinder and the head right here, there's a gasket that goes here, a crushable head gasket that'll get replaced. But I think even so, there's issues with these things, and you can see some oil. Zoom in there. Some oil right there. I think that's some blow by from a head gasket, and it's all cruddy here. And it's a similar story if you look at the actual cylinders. Open up cylinder 4 and look at it. There's a similar story of badness. You can see there's a bunch of cruddiness over here that looks like it's more than just dirtiness. This looks like it's all kind of chipped and gross, and I don't know what happened here, but I think there might have been some blow-by right there, the exhaust. That stinks if I have to end up replacing this cylinder. So I'm gonna have to talk about it with my machinist. What I need to do today is I'm gonna tear down the heads. I'm not gonna take the valves out. The shop wants to do that and kind of inspect their condition. But we'll take the cam out, we'll take the rockers off, and we'll separate the 6 individual heads. Now, why this remachining work is another issue too is it's not like they can just take off a little bit of material right at the top of one cylinder, because all 3 cylinders have to equally share the load of the clamping of the head studs when this thing is all bolted together. So if you had one short cylinder, it would not be clamped as firmly as the other 2. And so you wouldn't get a good seal on the top. So if they have to remachine this, they'll have to, fly cut the top of this, likely have to remachine the surfaces, but do it on all the cylinders, at least on that bank. And I suspect they do it on both sides, because if you're cutting into the head, this also changes the compression ratio. You get a higher compression ratio because the piston would actually be getting a little closer to the head. So I think I'm going to have to get all that machining work done, and that's a bummer because it's expensive. But the upside is going to be that when I put this back together, I think I'm going to go to a higher compression ratio piston. That'll make more power, and this will be more of a hot rod. So that's where we stand, and I think I'd have to at least do the fly cut machining anyway, just to fix the head. So while that's being done, I'm also going to get the bores done and Nickel coated. I also I found out that these are Alusil bores, which are it's a really funky heat treatment coating where it makes a really hard, almost like ceramic silicone coating. I think that's what most of the surface is made of, but it wears really well, and you can see inside. You can still see some of the honing marks, which is good. The problem is I can't just swap in new pistons to this because it needs like a really hard ring so it doesn't eat the piston, or So I need to reline these and then put them back in, and relining them, getting it redone, the surface treatment redone with Nikasil is a lot more cost effective than buying whole new cylinders. It's about, looks like it's about, boy, like a fourth the cost. The first thing I need to do is scribe the number of the cylinder onto the head, so I can put it all back together the way it came apart. I'm going to do it on this surface right here because this is not a sealing surface. IV. All right, so next up, I need to take out the rocker shafts. I'm going to start on this exhaust side because I've got access right here to an Allen key. All right, so hopefully this comes out without much fuss. Yep, cool. That was easy. So, unscrew this. And there should be a kind of a conical washer on one side. Yep. So here's the retaining bolt, and you see that washer is kind of conical. And then the other side, actually I can just push this out with my finger. That's great. Perfect. And then you just lift the rocker off. So this is going to be a bit of a moment of truth looking at these guys. What I have to be looking for is how this surface looks. This is a ground mated surface that runs on the cam inside there. And what this rocker does is it runs on the cam lobe. The cam lobe is kind of egg-shaped. And so when it gets to the sharp part of the egg, it pushes up on this. The rocker rocks, and then the tappet pushes down on the top of the spring that is supporting the valve. And that's what opens the valve. It actually pushes down on the top of the valve, compresses the spring, and lets the valve open up, and in this case, lets the exhaust out. So these are quite precision parts. This surface right here needs to match the cam itself. They recommend that you get these reground so they're totally flat if you do use a new cam, and I think that's probably what I'm going to have to do, which is cheaper than buying these new. These are like 125 bucks each new, and there's 12 of them throughout the engine. I should be able to push on this. There we go. Ooh. I crunch my finger right there. There we go. So put all these together and keep them together and remember that they're for exhaust side cylinder 4, because I'm going to want to put them back in the exact same place when I reassemble the engine. I've taken all the rockers off and all the shafts and labeled them in each of their bags, separate bags. So here's cylinder 4, rocker and shaft from the intake side, 5, 6, and then 4, 5, 6. Now I should be able to just pull out the camshaft with a little bit of wiggling. Ooh. It's got this nice viscous tight clearance feeling from all the bearings. Ooh, come on. I have never done this before. This is exciting. So it's cool that the bore of the bearings in the journals is just aluminum. And I'm sure they do some sort of honing on it to get it nice and smooth. But here we go. Here is the camshaft, and it looks pretty good at first glance. Let's look at the cam lobes. So here you can see there's no touching really, no rubbing there. And then this is where you get higher pushing forces. This is the egg shape of the cam. So as this spins around, this high point is what pushes on the rocker and is what opens the valve. And so what I want to look at is, are there any kind of scrapes or gouges in these cam lobes? And there don't seem to be. Looks pretty good. That's good. It doesn't matter though, really, because I'm going to get this reground to get more of an aggressive profile put on to make more of a racy engine. I think the last thing I'm going to do is, there's a bunch of nuts here. It looks like about 18, 9 per side, that hold the cam housing onto the heads. And I want to take those off because I want to see the individual heads. I think head 4 is going to be the problem child of this. I think that's what was puking all the oil. It just takes a little bit of prying, and I'm being careful here to not pry on any sealing surfaces. So like right here, got 2 dirty surfaces that don't mate to anything, and I can just sneak in there with a screwdriver and push a little bit and try to break this head free, and voila. Oh, look at that. Nice. So here we go. There, you can see the top of the valves. Here's the intake, here's the exhaust. The studs in the head look pretty good that are in there. So the spark plug goes. The head studs go down through there. 4 head studs per head. Well, here we are. I am finished tearing down the engine, finally, after a couple months of whittling away at it through a number of the weekends. But here it is all laid out. So anyway, that is the end of a long saga. This was pretty cool to see everything get torn down and see how it's all put together. I photographed basically every step and labeled all these bags, so hopefully it'll go together somewhat easily. Most all of these parts are going off to the machine shop though to at least get cleaned, if not get remachined when necessary. So definitely the heads will get machined and new valve guides will get put in. I don't think we'll have to machine the block at all. They're pretty stout, as my machinist said. So hopefully it just gets bathed and it's ready to go. But yeah, it's pretty gratifying to see this all laid out and finally all finished. So I'm looking forward to the next part of the saga.